All right, welcome to 5.1 notes. What is a solution? Today we're starting chapter 5, which is all about something called systems of equations. We'll take a look at that a little bit further as we continue through the notes today. But for right now, we're focusing specifically on identifying if something is a solution. So for this first problem that we're looking at on the front page, we're asked to identify which line contains the point 4 comma 2. Is it y equals 3x minus 10 or y equals negative 3 over 2x plus 8? Now, this is a very fancy way, or another way that you could rephrase this question is 4 comma 2 a point on the line y equals 3x minus 10, or is 4 comma 2 a point on the line y equals negative 3x plus 8? Either way you slice it, either way you look at the problem, we're just going to go ahead and graph each one of these lines and see which one, or if any of them, has 4 comma 2 as a point on the line. So as usual, the way I do this, I'm going to color code my lines. So for this first one, y equals 3x minus 10, I'm just going to use blue to graph that line. For this equation, y equals 3x minus 10, the minus 10, that's my b value for my slope-intercept form. That tells me that negative 10 is my y-intercept. So I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's that point right there. And the slope, which is always the number attached to x, I go up 3, 2, 3, over 1. And I'll go ahead and just connect those two dots. Now I have the magic of, it's not really wanting to behave today. Let's try that again. There we go. So now we've got that line, throw arrows on the end. So if you look, is 4 comma 2 a point on that line? I go up, right 2, up 4. That's this point that I'm highlighting right now. It is a point on that line. Now that doesn't necessarily mean that it couldn't be a point on both lines. So I'm going to go ahead and check the other equation as well. All I can say is that I know that it's a point on my blue line so far. So for the red graph, which is my right equation, negative 3 over 2 is my slope, positive 8 is my y-intercept. So I'm going to go to positive 8. I'm going to plot my point. Negative 3 over 2 is my slope. So for that, depending again on which way your brain likes to think, either down 3 and right 2, you could say up 3 and left 2, doesn't matter, down 3 over 2, or up 3 and left 2. Either way you slice it, you get the same line. So if we go ahead and connect my 2 points, hey, look at that. It does still pass through my point that I'm trying to see, which in this case is 4 comma 2. So in this case, I would say that both lines contain the point 4 comma 2. So if I was trying to do it graphically, so using my graph, that's how I would handle it. If I was asked the same question, but we're asked to do it algebraically, if we're checking to see if the line contains the point, remember, all the points on my line, if I look at my graph, those are all x and y values that work in my equation. So if I picked out any two x and y values and they work in my equation, if I plug them both in and my equation is true, that tells me that it is a point on my line. So our way of verifying this is to go ahead and just plug those numbers in, 4 for my x value, 2 for my y value, into each of those two equations to make sure that it works. It makes my equation true. What I have on the left side is equivalent to what's on the right. So if I do that with my left equation, y equals 3x minus 10, my y value is 2, 3 is still my slope, my x value is 4 minus 10. So all I'm doing is substituting 2 in there for y, 4 in there for x. So just some simple algebra, order of operations, 3 times 4 is 12, minus 10 gives me that 2 equals 2. Hey, that's good, I get the same thing on both sides, so it does work. So that's my algebraic way of showing that 4 comma 2 is a point on my line. I'll do the same thing over here. I'll switch to red again. For my second equation, y equals negative 3 over 2x plus 8. A little bit uglier, but still the same process. I'm still going to plug in 2 for my y value, negative 3 halves 4 for my x, and then plus 8. So it really depends on your personal preference on how you handle the negative 3 over 2 times 4. If you're multiply your numerators and then divide, you would be looking at this problem as negative 3 times 4, which is 12, divided by 2 is 6, so negative 6. If you are a reducing person, which is how I am, I see this as negative 3 over 2 times 4 over 1. I would reduce my 4 and my 2 by 2. And then again, negative 3 times 2 is still a negative 6. So that's your personal preference. It's up to your philosophical beliefs, whatever you see that as or you recognize that as. It's up to you. You can always use a calculator as well. You can always go to your calculator and just say negative 3 divided by 2, which is a negative 1.5. Negative 1.5 times 4, again, gets you negative 6. But from here, negative 6 plus 8 is a positive 2. So I do, again, end up at 2 equals 2, which is what I want. So I'm just putting that little check mark there, just saying, yes, it works. So that's our algebraic way of showing that a point is on each of the lines. So if we flip it on over to the second page, this is just getting some vocabulary and what we're talking about here, because if you didn't realize, we've been looking at two equations working simultaneously, and that's really what we're going to be doing this chapter. It's dealing with something called a system of linear equations. A system of linear equations is a set of two or more linear equations in the same variables. So again, we have, for our purposes, for at least Algebra 1 level questions, we're always going to be dealing with two equations. They're both going to be linear. Sometimes they'll be in slope-intercept form. Sometimes they'll be in standard form. Sometimes they'll be in other forms. But really the important thing here to know is that they're using the same variables. So both of my equations that I looked at on the front side were both x and y. And the important thing is that those x and y values mean the same thing. So once we get to doing some problems, x in one equation is the same as x in any other equation. Y in one equation means the same thing in any of my equations. A system of this, a solution of the system, just like a solution of an equation, is a set of ordered pairs. So in this case, an x and a y value that works in my equations. But in order for it to be a solution to the entire system, it's going to be an ordered pair that is a solution to all equations in the system. So it has to work everywhere in all of the equations. So again, for us, it's going to be just two equations, so a point, an x and a y value, an ordered pair that works in both equations. For when we start getting to like Algebra 2, that first chapter that we have, we'll have three variable system of equations, so we'll have sets of three equations. And again, it just has to work for all equations in my system. So if we come back to our example that we've been dealing with, so for the system of equations y equals 3x minus 10 and y equals negative 3 over 2x plus 8, the point 4 comma 2 is a solution to this system because it works, or it is a solution to both equations in my system. Another way of saying it, and something that we'll get to moving forward, it is where the lines intersect. So that's something we'll get to eventually. We'll get to the point where we're asked to solve a system of equations. So we're just given the two equations and asked to find what is the solution. And for that, one way we're going to do it is just solve something called solve by graphing, where we're just going to graph my two lines. Wherever they intersect with each other, that point we know is a solution to both equations, so that's going to be my solution to the system. So I'm going to just do one of these two problems. Maybe we'll do both. Yeah, we'll go through and do both of these. So looking at our two practice problems here, number 1 and number 2, this is the exact format that your homework is going to be. It's just presented to you as identifying if the point is a solution to the system. And you're asked to do it both graphically and algebraically. So we'll do it graphically for one, algebraically for the other. Just know that on your homework, you're expected to do both. Just to get used to it, it's going to be up to you moving forward which way you prefer to check to see if a point is a solution to the system. But just for us, just to get a little taste and not to ramble on for too long in this video, we'll go ahead and just do it algebraically first. So for this, is negative 3 comma 2 a solution to the system? Y equals 2x plus 8 and y equals negative x, or sorry, just y equals negative x. This is the same thing, or this is really asking, does negative 3 comma 2 work in both equations? So that's the question I'm really trying to answer if I'm going to do it algebraically. So again here, I'm going to plug in negative 3 for my x value, 2 for my y value into each of my two equations. So if I test the top one in this case algebraically, which is y equals 2x plus 8, my y value is 2, my x value is negative 3 plus 8. So 2 times negative 3 is negative 6, plus 8, 2 equals 2. So that works in my first one. So far, so good. It's a solution to my first point, or sorry, to my first equation. But in order for it to be a solution to the system, it has to work in both of my equations. So if I plug in, again, I'll switch to my red for my bottom one in this case, my equation y equals negative x. If I plug in 2 for my y value, negative 3 for my x value, I get 2 equals 3, which is not equivalent. That is not true. So in this case, since it doesn't work in both of my equations, I come to the conclusion that no, it is not a solution. I don't like how big that turned out. Let's shrink you down a little bit. No, it is not a solution. So you can say no because it's phrased as a question here. Is it a solution? So you could say yes or no. Most of the time, we'll go ahead and just say not a solution is another option for us. That's the nicer way, the more formal way of saying it. If you don't like that and you like just making extreme statements, shout no at your paper. Go for gold. Okay. So that's algebraically. Again, you would then go ahead and graph each of the two lines. In this case, you would see that the point negative 3 comma 2 is on the top line, but not on the bottom line. So for number 2 here, if we're trying to go ahead and check to see if negative 4 comma 0 is a solution from this system of equations graphically, we would graph each of my two lines. So my top one, I'll do bottom in blue, top in red. So for my top graph in red, my y-intercept is negative 2, which is right there. Ooh, zoom back out. Is negative 2. My slope is negative 1/2, so down 1 over 2 is those 2 points right there. So I'll go ahead and grab my ruler, grab whatever you want to do to connect your two dots. Down 2 over 1, over 1, over 1. So I'm going to go here, try and line it up as best as I can. There we go. And then I'll switch to blue for my bottom equation. This one is just x plus 4. So that tells me my y-intercept is 1, 2, 3, 4. My slope of positive 1 is just up 1 over 1. So that means, let it lock in place. Right there is my equation. And if I look, negative 4, 0 is the point that they're wanting me to check, which is right here, negative 4 comma 0. I can see that it is a point on both of my lines. So, no, not yell, yes. Or you can just say it is a solution. And again, for your homework, moving forward, if you're asked to do both, which your homework asks you to do both, you would just plug in -4 for x, 0 for y into both equations and show that it is a solution. All right, so those are all the algebraic types of equations that we'll have, so where it's just equations, there's no context to it. But we know we are going to have word problems. There are going to be things we have to do with context, so we have to be able to handle those as well. So when we're looking at these, basically all we're doing, we're taking a problem like we did last chapter where we have to write the equation of the line from a given context. It's just that we're doing it twice. We'll have scenario A, scenario B, and then we'll see how they interact with each other. So for this given problem with our context, Fiona, our friend Fiona, bought two sunflower plants. Their height and their growth rates are shown below. So for sunflower A, it starts with a height of 8 inches, and it grows 3 inches per week. And sunflower B starts off at 14 inches, but it only grows 2 inches per week. So this information, with this information, we should be able to figure out what each of the different variables represents, and then also write the equation as well. So for this, for our two pieces of given information, the starting height would be my B value, right? We talked about this, our starting value, our initial cost, our initial fee, our initial whatever starting thing is always the B value. So I apologize, you have to kind of flip back and forth. It printed out kind of funky-dunky. But for my B value, if I'm just describing what those represent, my B value is my starting, I think my pen got a little bit big. Let's try that again. Yes, it did. My starting height, and that's always going to be, in this case, in inches. My slope in this case, again, looking for that per that we talked about back in chapter 4. They're giving me my growth rate in inches per week. So M, my slope, is going to be my growth rate. In this case, it's going to be inches per week. So that tells me if those are my two variables, my two unknowns, my two values that I'll be substituting into my equation, I should also be able to describe what x and y are. And those are the more important things. In this case, my two variables, my two things that are going to change, if we're looking at the height of the flower and then how long it's being grown for, x is always going to be time, in this case, measured in weeks. And then y value is going to be the height of my flower, and that, of course, is going to be measured in inches. So I have the luxury of doing this, where I can just copy it and paste it over. As we talked about earlier, my variables in a system mean the same thing. In this case, sunflower A and sunflower B all have the exact same x, y, b, and slope values. So in my actual equation for sunflower A, since it starts off 8 inches tall but grows 3 inches per week, y equals 3x plus 8. And for sunflower B, y equals 2x plus 14. Those are my two equations. So if we go back to the second page here, that's why I gave you guys the spot for the second to rewrite it. Y equals 3x plus 8. Y equals 2x plus 14. Again, this is something that, depending on the problem, it might ask you to do. It might not ask you to do. I know on the homework problem like this tonight that you guys will have to do, you do have to define what each of the variables represents, what each letter represents. When you get to a word problem like on the test or on the quiz or test, it really depends if it asks you to define your variables or not. If all it does is gives you this information about each of the different scenarios and just asks you, which one's the better deal or when are their values going to be equivalent. You don't have to necessarily do that. All right, so looking on the back side, if we wanted to graph these to see where they intersect, because they want us to try and figure out what's the solution to this equation. And without just guessing and checking and plugging stuff in, again, solve by graphing is the easiest way to do that, where we can just go ahead, graph my two lines, the point where they intersect, we know is a solution to each of the two equations. So since it's common between the two of them, then we're good. So in this case, I've already kind of got it laid out for us. My x values, we said, were time, and that's measured in weeks. My y value is my height, measured in inches. So if I'm going to graph each of my two lines, sunflower A, again, I'll just do that in blue. I'll switch sunflower B over to red, just so we can see the distinction between the two. So for sunflower A, it had a y-intercept of positive 8, which is right here. Make sure you're paying attention because my graph is scaled by 2s. So for that, a slope of 3 would be up 3 over 1. On my graph here, because my y value is scaled by 2s, but my x value is scaled by 1s, that means I'm going up 1.5 units over 1. That would be 3 total, right, up from 8 to 11. So just to make it a little bit nicer and cleaner, I'm going to go up to the next one as well. So from that second point that I just graphed, I'm going to go up another 3 units and over 1 more, because it's nicer for us to look at how much it grows over 2 weeks, because then that's still an even number. It works out on my nice grid marker point. So I'm going to go ahead and connect my dots here, which is right there. So then from here, I'm going to go ahead and switch to red. My other equation was y equals 2x plus 14. So now I start at 14. That's my y-intercept. Since my slope is 2, now I grow 2 inches every week, which in this case, 2 inches is 1 block up, 1 block over. And again, I go ahead and just connect my dots. Let's line them up. There we go. So with this, you can see not the most accurate, because the way I have it right now, it looks like they intersect in the middle of space there. So this is, again, why graphing with precision is really important. If I kept going with my slopes, so like for my blue graph, I switch back over, basically my slope, the way it appears in my graph, is up 3 over 2, up 3 over 2, up 1, 2, 3 over 2, which actually tells me my graph is a little bit off. That blue point that I just graphed is where my line should actually go through. This point right here is 6, 26. So if I zoom back out a little bit, you can see the x value is 6, the y value is 26. So this line that I have in blue is not accurate. I should be going right about there. That's more correct. So 6, 26 is where those two lines intersect. So 6, 26 should be my solution. So 6, 26 should be my solution. It is my solution. It's where my two lines intersect. What does the solution mean? Well, again, if it's the same, if there's an x and y value that work in both of my two equations, that tells me that both sunflowers will be 26 inches tall after 6 weeks. It's the time where they're both the same height. It really depends on how you want to explain that. For the last part, can we prove this answer algebraically? Well, sure. If we were thinking that 6, 26 is a solution to both of my two equations, I'm just going to take 6, 26 and plug it into both of my two equations. So for sunflower A, which was y equals 3x plus 8, if I plug in 6 comma 26, 26 is my y value, 6 is my x value, 26 equals 18 plus 8, which is 26 equals 26. So we're good so far. If I do the same thing with y equals 2x plus 14, which is my equation for for sunflower B, 26 equals 2 times 6 plus 14. 26 equals 12 plus 14, and 26 equals 26, which it does, so it is. All right, that's all I got for you. Hopefully it wasn't too bad. If you are confused, obviously the power of video is you can go back and listen to it again. You can pause. You can fast forward through stuff you understand the second time around. Listen to me as many times as you want to or can bear. Your homework, which the sub has, is just a worksheet. So it's, is this a solution, or sorry, what is a solution homework? Again, it's very similar to what we were doing today in class. It is 3 problems where I give you the system and give you a point and just ask you to identify if it is a solution. For that, again, you're asked to do that both algebraically and graphically. And then on the back side of your worksheet is 2 problems, basically like what we did together just now. You're asked to define the variables for each of the 2 different companies, and then write the equation, compare their solutions for 2 of those problems. So if you have any questions, feel free to email me. Again, watch this again. Try and reach out to your peers for help. Otherwise, have a good one.